In exercise number 3, we have the following problem. We have the cosine of some unknown angle is equal to 5/13, and that angle is in quadrant 4. So let's draw out a picture of what's going on. Here's our unit circle. Okay. And we've got an angle that starts out here and ends somewhere down here. It has some intersection point with the unit circle. This is our angle. Called theta. So now if we draw this out, if we drop a vertical back down, I should say up, I guess to the positive x-axis, this point right here at the intersection, its x-coordinate is the cosine of theta, and its y-coordinate is the sine of theta. So we know that its x-coordinate is 5/13. The question is, and that's, by the way, that's this length right here. This length in green, that's 5/13. The length here in blue, we don't know. But that's what we want to know. So we know that because it's a right triangle, if we square the two smaller sides, we'll get the larger side, the longest, the hypotenuse, squared. So we've got 5/13 squared plus, remember that 5/13 is this green length. The blue length we don't know. That's what we want to know. That blue length is sine squared. Well, it's sine theta. So if we square that, we get sine squared theta. And that should be equal to the hypotenuse squared. And the hypotenuse, since we're on the unit circle, the length of the hypotenuse, I'll mark it here, is 1. So 1 squared, which is just 1. And that's the formula. So let's go ahead and do this math out. Okay, so this is just algebra now. So we'll take the 5/13 squared to get 25/169 plus sine squared theta is equal to 1. Now we're going to subtract 25/169 from both sides. And we're going to end up with sine squared theta is equal to 144/169. So now we'll take the square root of both sides. Now remember, when we do that, we got to do plus or minus. So the left side just becomes sine theta. The right side becomes plus or minus 12/13. Now we're dealing with sine, and we're in quadrant 4. So sine in quadrant 4 is negative. Therefore, we're going to pick the negative value. So to answer the question, we have the sine of the angle. Now notice I didn't tell you what the angle was. At no point in this did we determine what degree measurement that angle was. But I can tell you that the sine of that angle is equal to -12/13.